Hello there, this is a very rusted and abused Lionel RW Transformer. It actually is a great transformer. It doesn't have the same cachet as the 1033 does, which is rated at 90 watts. This one has 110 watt rating, and it is a great transformer, particularly for your accessories and your lights on your layouts. This one has seen better days, and just looking at it is heavily rusted in many places, so we're going to have to take care of that. The power cord is an original Lionel power cord, and this thing was made way back in the early 50s, so we're going to have to replace that and not take any risks with the power cord. And we'll also replace the rectifier disc with a rectifier diode, and we'll take a look at the circuit breaker and see whether that needs to be replaced and put in a thermal breaker if that's indicated. So there's a lot of work that has to be done and a lot of parts that have to go into this. The whole point of taking care of these old fellers is to bring them back to their original luster. You can use them for another 75 years or so, so that's what we're going to do here. We're going to make sure that this fella has another life ahead of him of another 75 or more years as a fantastic workhorse on people's layouts, people who are not even born yet. Okay, so let's get down to it. As you can see, there are 4 flat-bladed screws to take off the metal cover. Here, here, and here. Once those are off, and you've taken off the hardware on top, then you have an easy way of taking the entire metal case off. Looking at the pins here, you have a really good selection of voltage, especially for accessories. The great thing about this transformer is that it does not have carbon rollers. It has a copper arm, and so you don't wind up burning out graphite and losing your rollers. Here it can stay for an extended period of time in usage, which is great for accessories. So now we're going to take the case off, and let's go see what's inside and what we're going to have to do inside. Here we are now at video number 3. I've taken the case off. We have the bearing plate platform here on top. It has 4 tabs that you can see here. These were bent a bit in order to hold the platform in place, and then what you have to do is to take a good sturdy pair of pliers and straighten them out so that they come up and out, and they're very tight. Also, that's what also holds the rectifier plate. We're going to get rid of a lot of this stuff when we put in the diode, so that's not going to be our problem. In order to liberate the bottom plate from the rest of the transformer, there's a few wires that have to be unsoldered. They all connect down here, as you can see, to the circuit breaker. So these 2 wires have to come off, these 2 wires have to come off, and also we have the 2 connectors to the power cord. When we replace the power cord, we will address these, and I'll give you some information on how best to do that. Otherwise, the core can lift out, and then we will clean up and then repaint the bottom plate of the transformer. Now, there's a couple of things you ought to know about the connectors. Anything involving the C connector is not passing with the protection of the circuit breaker. Make sure that anything involving the C connector, that would bypass that protection. So be aware of that and make other plans to protect from short circuits or overloads. Okay? I'll come back to you when I've got those wires unsoldered, and we'll go on from there. Now, as you can see, we have taken off the wires connecting to the circuit breaker down here. It may look like a colossal mess, and in a sense I suppose it is, but we have liberated just about everything. The last thing I have to do is to bend this bracketing that's keeping the core in place, and once I do that, I'll lift out the core, which is going to have I'm going to have to bend a whole bunch of stuff to do that, but get the core out and then have everything on the table freed from the bottom plate, the base plate of the transformer. Then I'll clean up the base plate and paint that as well, and then we are in business to then go ahead and do things. The next thing that has to be done is getting the 2 connectors for the power cord liberated. So let's just do that right now. It's not a complicated thing to do, and you'll see what we do in a moment. Just you can do that. All right, I can see the sizzle of the. Let me get one of those pliers to pull that away when the solder is gone, so I don't burn my fingers. Come on, you can do it. Come on. Come on. There's one. Okay. And we'll do the second one over here. And you'll see the little trick that we do when we do the power cord. I have a, you don't have to buy a train power cord. It's just a plain, there's no ground on it. There's no polarity to it. It's just a simple 2-prong power cord. And you get it at any hardware store for a few bucks. It's no big fancy thing. That's all you need to do. You don't have to buy a special Lionel or L power cord or any such thing that you have to spend like $7 or $8 for. Like on eBay, you're going to wind up paying shipping on it too, and it's going to be a mess. Okay, so now we have the power cord liberated from its connector, and here you see how we have the back plate, and then there's a knot here that prevents the power cord from being pulled through the back plate, and that prevents the power cord from being pulled off of the 2 connecting points here. So the power cord goes underneath the core, and there we go, voila. And then we can unknot here. Come on, there we go, there we go. All right, power cord is gone. We have a new power cord to take its place. All that's got to do is I'm going to put the power cord through that slot, bring it underneath the core, and have a knot behind here, and then just attach there. So we'll do that in another video. But in the meantime, let's get this core out. I have to bend these brackets a bit and to liberate the core, and then we'll go on from there. Okay, let's see where we are now. You can see pretty much the different component parts to this transformer. This is the base plate. I got it cleaned up a little bit. We're going to paint it maybe tomorrow. It's supposed to be a nice, dry, sunny day tomorrow. We'll do that. That takes care of that. We're going to put in a new power cord. This is the rectifier assembly here. We're going to see more of that later. And this is the bearing plate with all the, you can see here, now this is one thing that's important. See this copper arm that has the little dimple on it? This is what makes this particular transformer great for accessories. A lot of other transformers like the KW and the ZWs have rollers, graphite rollers. And if you put the accessories on a constant voltage, those graphite rollers degrade. They get brittle, they break, and then you have to open up your transformer and replace them. In the meantime, you don't have a working transformer. This copper arm with the dimple on it does not do that. It slides along the windings of the transformer, and that's what you see here. You can see this curve here. That's where this arm goes. It just slides across here, and the farther it goes along, then that means the higher the voltage you're going to receive because you're accessing a greater number of windings. Okay, so it's perfect for accessories because that copper arm does not degrade. It just sits there where you want it, stays there, and you have no problems with any disintegration of components of your transformer. So that's that. So now what I think we're going to do is I'm going to put the cord through here, and I just have to solder these 2 points. That's not very interesting to see. And then when that's done, then I'm going to start working on the diode that's going to replace the rectifier disc. We've got a bit of work to do on that, and then we'll see what we do. So let me take care of the power cord, and I'll be back to you. We have made a bit of progress here. Had to change the battery in the camera, so I lost a film. But let me show you what we did with the power cord. The first thing you do is you pass the business end of the power cord that's going to hook up to the core through the slot here in the back plate. And you bring it back about a foot or so, and then you make a knot. Just a simple simple knot. And then that's to prevent the power cord from being pulled through the back plate. Then it goes underneath the core, and then just you poke it down through the two slots to connect the power cord to the core. What I like to do, and what I've done almost all the time, is whenever I have to do a power cord, I take a toothpick and my soldering gun, and I melt the solder and poke the hole with the toothpick so that I get a nice opening to put the end of the power cord through. It's a really good little tip to do, and the toothpick does a great job. It doesn't interfere with anything, and it may scorch a little bit, but it doesn't cause a fire. It just makes it work better. Okay, so that's the power cord. So now we go on to the rectifier disc. We had the rectifier disc connected here to the rectifier plate. And now we got rid of the rectifier plate, we got rid of the rectifier disc, we got rid of the pin, the spacer, and the speed nut. The speed nut, all you do is lift it up with a tiny little edge of a flat-bladed screwdriver, and it'll come right off. What we're going to do is going to solder 2 points. This is a diode, or the anode of the diode. Connect to the yellow wire, and the other end of it is going to go onto this copper arm that you see here. Now that the rectifier disc plate is gone, this thing can be moved easily back and forth. And so what we're going to do is put the stripe end is going to be soldered here, and then the other end is going to be soldered along here. And we're going to insulate on both of them so that we don't short out anything in the process. So I'm putting a simple sleeve, insulating sleeve, through here, and then I'm going to push it down so that when I finally do make the connection up here, I can, with the diode, I can just simply move this up and shrink it with heat. And that's all there is to it, folks. And I now have the diode in place, and that should cover things pretty nicely. Just put some heat on it to shrink it, and we're in business. That's all there is to it. We'll find out whether or not it works when we put everything back together. Right now, that looks pretty darn good. So now I've taken care of the rectifier disc by replacing it with a diode. We put a new power cord on. I don't see any reason right now to replace the circuit breaker. I'll do a bench test on the circuit breaker and see if it needs anything. We're in pretty darn good shape right now. We still have to, putting it back together is going to be a bit of a bear because these things are cantankerous. I think I'm just going to polish up some of these electrical points. For example, this is a contact point. I'll get the Dremel out and I'll just polish that up and polish the dimple on the copper arm. And also I'm going to clean up this here with a little bit of alcohol. And then I've got to do some masking of the cover. I'm going to mask this, and then I'm going to Dremel away pitted paint that's along here. There's a lot of pitted paint here, a lot of rust. Once this is masked, I will put on a coat or 2 or 3 of some black paint. And then we start putting it back together, and then we try it out and see if it works. Alrighty. See you after we do the painting on the base and on the cover, and after that we should be able to put this buddy back together again and hope for the best. Okay, we've painted the cover of the Transformer after sanding it down and cleaning it up. We had to wash it first with a toothbrush and some dishwashing detergent. So it looks fantastic right now. It looks brand new. The paint job came out beautifully on that too. It looks wonderful. So we're going to put the core back in. We have some bracketing that needs to be moved around in order to get the core in place. Let's see, can we get this in here too? That has to go underneath. This has to come out. And that goes in. Let's see, pull this out a bit. That goes down. Oh, look at this. That looks beautiful. Very nice. Now, these brackets here that were bent in, I'm going to bend them in again. These were curved into place here. So I'm going to bend them back into place. So they're not going to touch any components, but I'm going to bend them in so that it holds the core. That's great. Oh, that's great. So now the bracket, the core is in place. Well, I want to get all the wires that need to be attended to. Let's put things back bit by bit and have faith that if you try it yourself, you can still do it. These two larger rectangular tabs go to the two tabs on the whistle button assembly. Well, I wrestled the bearing plate back into place. All right, these 4 points are well isolated. We've got the whistle button in place. So we've got in the front of the breaker here, let me show you here. In the front, we've got this wire from the core is the number 6 wire, I do believe. Yes, that's the 6 wire there. And then from the lamp assembly, we have the 7 wire. So these 2 wires are going to go down to this connecting point on the circuit breaker. Then we have 3 other wires. We have the wire coming from the C post, which is this one, and that is the number 5 wire. We have another wire coming from the core, that's the 8 wire. And then we have this resistor wire that comes from the lamp to the circuit breaker. So let me solder these guys in place. Then we will maneuver the back plate in place, put the cover on, hook it up, and give it a test. Well, I wrestled everything into place. We've got 4 screws now to put in to lock it all together. So let's start getting some of these screws back in. We got the 4 screws in the back plate. Now we only have to put on the jewel. Got that cleaned up. Look how beautifully all these cleaned up. They're shiny as can be. Here's the handle for speed control. There we go. That's it. Now let's put a test track up here. I'm going to plug it in and use my multimeter to see what the voltage performance is. So let's do that right now. It's plugged in with a very faint hum, which is encouraging. That means the power cord is done correctly. And I'm going to turn this sideways. If we do A and U, we should get 19 volts. If we do B and U, we should get 15 volts. If we do B and D, we should get 15. If we do A and C, we should get 9. And if we do these two, both C and D, we should get 10 volts on there. So let's see what we're going to do. Get our multimeter going. Alrighty. And just turn up the throttle. And let's go to A and U and see what we get on our multimeter. There we go. We got the 19 volts right there. Let's do B. There's the 15. It comes out at 6 meters. That's the 15 volt measure. All right. Then we do the D and the A. And there's the 19 volts as promised. And then we'll do the C and the A. And there's the 9 volts as promised. And then we should get 10 with these two. And then there it is. So perfect. We have perfect readouts for the voltage on this unit. So let's put a train on and we'll see, and a whistle tender, and we'll just see how well it works with the track and the whistle tender, especially the whistle tender. Alright, let's get an old whistle tender and see how this baby works on here. That's good. Get the diode works perfectly with the whistle tender. Unbelievable. That's great. Okay, I'm going to take this old feller, which is a 2055, and it needs some restoration in itself. Turn this down a bit. Let's put this baby on and see what we have. That's great. right. We have a perfectly functioning, thank you very much, 2055. You did a fine job there. Bench tested. Turn you off. Thank you too much. We now have a renovated RW transformer that performs precisely as it's designed to perform. We have a new whistle diode in there in lieu of the rectifier disc, which is giving a crisp and strong and non-lingering whistle when activated. We've got all the voltages entirely the way they should be. The reversing unit works perfectly. So folks, I think this is a tremendous success. I hope you enjoyed this particular episode. And if you have one of these old beauties, before you throw it out or just give it away or whatever it might be, these can be restored. That's it. Thanks so much for watching, and enjoy operating your trains. Have a great one.